Okay, so as we said, in underwater welding there are two types of welding. One is wet welding, second one is dry welding. In wet welding, the welder goes underwater and performs the welding underwater while directly exposed to the wet environment. In dry welding, a dry chamber is created near the area to be welded, and the welder does the job by staying inside the chamber, and the water inside the chamber is replaced by some gas, some breathable gas. Okay, so we will first get to know about the wet welding. So wet welding, as the name indicates, the welding is performed underwater while directly exposed to the wet environment. That means directly exposed in the water. So what is the important point here then? A special electrode is used. Normal electrode are not waterproof, and so that's why they will not work. So special type of electrode is used, and welding is carried out manually. Welding is carried out manually. Now manually means just the way we perform SMAW or manual metal arc welding, MMAW, in air. Since similar process underwater, we weld it manually. Now then what is the facility here? The increased freedom of movement compared to the dry welding, because you are free to move, you are free to, there are sufficient space and you can move here and there to make yourself on perfect position for welding. So that becomes easier to weld. So free to move, or free to say movement. So that's why it is most effective, efficient, efficient and economical method. Now the welding power supply is located above the, sorry, what I have written, above the water surface, probably on a boat or on a vessel, and connected via well insulated cable and knife edge switches. We'll discuss why these are required. The power supply is DC, and polarity is straight polarity.
Knife edge switch. Okay, sir.
Polarity is straight. Straight means I mean not straight here. Just a second. Electrode normally taken negative. Electrode negative means job positive, electrode negative. That is job positive, electrode negative. Yes, that is straight polarity, right? So power supply is DC and polarity straight. Straight means the job will be positive and the electrode will be negative. So what is the principle? The process of underwater welding is such that the work is connected one side of the electric circuit with the positive end and the metal electrode to the other side. Now, other two parts of the circuit are brought together and then separated slightly. Just like MMAW, we first touch it and then we create a gap so that the electron transfer starts and later on they jumps. The electric current jumps the gap and causes the sustained spark, which is called arc, which melts the bare metal, forming a weld pool. At the same time, the tip of the electrode melts and the metal droplets are projected into the weld pool. During this operation, the flux covering the electrode melts to provide shielding gas. So here, flux is used, might be outside the electrode, might be inside the electrode. So maybe like SMAW outside, maybe like FCAW flux code, which is inside the electrode. Now, during this operation, the flux covering the electrode melts to provide the shielding gas, and which is also used to stabilize the arc column and shield the transfer of metal. Okay, so this is very easy process and very easily understandable process. Now we get to know about dry welding. In dry welding, in underwater, a dry environment is created. Dry environment is created, and it is possible by encompassing the area to be welded with a physical barrier that excludes water. So what we do is create a chamber which is of course waterproof and also non-leaking, watertight chamber. We create a watertight chamber which is custom built. So for different uh, cases, for different positions, for different places of welding, different chambers are to be made, so that the braces or fixtures or other structural members which are placed properly. Braces and fittings. That means basically different for different cases. So each time you need to make a separate chamber. The chamber is made of steel, mostly steel, but for very smaller cases like plywood, rubberized canvas, or any other.
স্যার এই যে এটা বুঝতে পারলাম না, what do you
Okay.
mean by chamber is made of steel but plywood, rubberized canvas or other suitable materials?
Let me complete this sentence. Now can you understand?
Yes sir, thank you sir.
Okay, so basically most of the cases the chamber is made of steel, but we also sometimes use plywood, rubberized canvas, or any other suitable material depending on the situation. The water inside the chamber is replaced by air or suitable gas mixture depending upon the water depth and pressure at work site. Okay, depending upon the water depth and pressure at work site. Now if we create a air filled or almost vacuum chamber, then there will be buoyancy which will try to lift the chamber from underwater to the surface, and that buoyancy of the chamber is offset by ballasts. Ballast means ballast tanks, which can be filled with water, or water can be taken out and can be filled with uh, airs depending on the situation. Like in submarine, the ballast tanks are used in submarines, and it helps to lift the submarine up or down. So in same way we use ballast here, and the ballast used by mechanical connections and the chamber to structure, or by a combination of both. So it might be fixed without ballast, might be with mechanical connection, fixed with fasteners, or it may be welded. Otherwise, balancer used ballast tanks are used, or in sometimes both are used. It depending on the situation and on the situation. I mean, uh, depending on the situation, and as well as depending on the availability of the materials. Okay, now we get a new term which is called hyperbaric welding. Hyperbaric welding. So what is it? The hyperbaric welding is carried out in the chamber sealed around the structure be welded. The chamber is filled with a gas. The gas should be breathable. A dry chamber is filled with helium containing 0.5 bar of oxygen at the prevailing pressure. The habitat is sealed onto the pipeline and filled with breathable mixture of helium and oxygen, or at slightly above the ambient pressure at which the welding takes place. So the pressure inside the chamber is slightly high than the ambient environment. The method produces high quality weld joints that meets X-ray and code requirements, and the gas tungsten arc welding process is employed for this process. So when dry welding, gas tungsten arc welding is used, and the area under the floor is open to water. So you must remember that the dry welding is done, which is GTAW, gas tungsten arc welding, and when the wet welding is done, then it is done in either FCAW or type of MMAW, manual or like MIG, but as FCAW means the flux is at the core of the electrode. Now we will know the risks involved. Now we get to know what are the risks. First risk is risk of electric shock. Electric shock. Okay, this is the main risk, because the diver will be underwater, under salty water of sea, and as a result, if anywhere the insulation get leaked, there is a chance of electric shock. So precautions include achieving adequate electrical insulation of the electrical and welding equipment, and shutting off of the electric supply immediately the arc is extinguished. That is provided. So proper insulation required, electric supply get shut off immediately the arc get extinguished. And limiting the open circuit voltage of welding sets. So this is also another same point, limiting the open circuit voltage OCV of the welding set. These all are done to keep the driver out of electric shock. Now precautions sorry precautions must be taken to avoid the building of pockets of gas. So build up of pockets of gases to be avoided, because this will work as explosive. Which are potentially explosive. The other main area of risk is to the life or the health of the welder or diver from nitrogen introduced into the bloodstream during the exposure to air at increased pressure. So risk to life or health of the welder from nitrogen introduced into the bloodstream during exposure to air at increased pressure. The precautions include the provision of an emergency air or gas supply. So the oxygen tanks are kept there. Standby drivers should be there in case of any emergency. The standby drivers must jump at the scene. And decompression chambers to avoid nitrogen narcosis following a rapid surfacing after saturation driving. So immediate the chamber to be decompressed to avoid nitrogen narcosis, just we have discussed it. And following the rapid surfacing, the diver should be taken at surface very fast whenever any difficulty is faced. So what to be done is to keep provision of emergency air or gas supply, and this gas includes non-reactive gas also, which will shut out the fire if in case of fire is required. Gases to be used, non-reactive gases to be used as fire extinguisher, like a shielding gas. Okay, so our remedies are, you have to keep emergency gas supply or air supply, emergency standby drivers, decompression chambers, to avoid nitrogen narcosis, following rapid surfacing after saturation diving. Okay, so for the structures being welded by wet underwater welding, inspection the following welding may be more difficult than for welds deposited in air. Weld we used to do in air is easier to inspect, but in this case of underwater welding, the inspection becomes very difficult, and there is a risk that the defects may go undetected. Now, so the conventional underweighting techniques are shielded metal arc welding or SMAW that we
যে
already
লাস্ট
know.
পয়েন্টটা লিখিনি স্যার, আফটার স্যাচুরেশন ডাইভিং এর পরে কি আপনি কিছু লিখেছিলেন?
Defects may go undetected.
ওকে স্যার, থ্যাংক ইউ।
The techniques you use is basically SMAW, but the flux are different. Sorry. The flux are different, and of course waterproof. Scavengers, deoxygizers, alloying elements are added. and rest of the things are similar. And the slag deposited are to be taken off by chipping. Slag are taken off by chipping with help of chipping hammer, as you have done in your workshop in second year. So all the difference is on flux composition, and these flux compositions are well maintained and well guided by American Welding Society. They look after different parameters and the quality and quantity of the flux, the composition of the flux, and the quality standards. All these are basically provided by different societies. But in India, we look as per the American Welding Society. This is also called AWS. We also use FCAW. Here also the flux is different and it is used like MIG, but there are some difficulties. Difficulties are wire feed system under water are problematic. That is a very large problem for FCAW. So that's why still we have not found any way to automate the process. So the future scopes are to think about robotic weldings, automation of the underwater weldings. So the characteristics of good underwater welding are summarized. That is the requirement of, I'll write it down. What are the characteristics of a good underwater welding? Point 1, requirement of inexpensive equipments. Low welding cost, should be easy to operate, and flexibility of operations in all positions. These are all positions desired. Next to minimum electrical hazards is desired, and minimum 20 centimeter per minute welding speed is also desired. Minimum 20 centimeter per minute should be permitted with good visibility. Number 4, produce good quality and reliable weights. Produce good quality and reliable welds. Number 5, the operator should be capable in supporting himself at the time of emergency and can be easily automated. So that cannot be done in underwater welding. Till date, the work is in still process. So the applications of underwater welding are in offshore constructions, for tapping sea resources. Number 2, temporary repair work which is caused by ship's collision or unexpected accidents, collision with icebergs. So in such cases, temporary repair work is done. Number 3, salvaging vessels sunk in sea. Underwater welding is required in some cases. Number 4, to repair and maintenance of ships. Sometimes for quick repair, for small repairs, these underwater weldings are used. Okay, so there are lots of future scopes also, like the automation, mechanized and robotized underwater welding. This can be done, and this is already under research. So if it is under research also that the if friction welding, laser welding, those can be done in underwater or not. I mean, how they can be done, research is already going on, but still more research is required. Okay, so any questions on underwater welding?
No, sir.
Okay.